Hey guys, welcome to the next video. So in the previous one, we covered how we synthesize an ether, right? And so in case you just need a quick refresher on an ether, I drew one right over here, and the general scheme for what it would look like is something like this, right? So an oxygen bound to two R groups, they could be the same or they could be different. So we learned how to synthesize one. Now we're going to learn how to break it apart, all right? So usually when dealing with ether cleavages, we have to break it using a strong acid, all right? So I'm going to draw here HBr. Right? And so we have this oxygen that's somewhat basic, and we have this HBr, which is a really strong acid, so that hydrogen is going to dissociate very easily. So this oxygen is going to grab this H. That bond is going to break, and we're going to get this intermediate. So we're going to have this protonated ether, and we're going to have Br minus. So we don't know, what do we know about Br minus? Well, Br minus is a good nucleophile, but it's also a bad base, right? So at some point here, we're going to need to break one of these bonds. So it's going to be either that bond or it's going to be that bond. So we get an alcohol, right? Because remember, we want to break the ether. So which one are we going to choose? Well, if you remember from your when you guys learned substitution and elimination with alcohols, specifically with the strong acid, right? We learned that a tertiary alcohol, which is somewhat what we have right here, right? This carbon is bound to three other carbons, right? And now we have this alcohol looking thing here. And so we're going to go through an SN1 mechanism, which means that this bond right here is going to break and that's going to come up. So what we're going to get is something like this. So we have this tertiary carbocation. We have this, and this is a methyl, right? So we're going to have this. We have our alcohol, and we still have our Br minus. The next thing that's going to happen is the Br minus is going to come in and attack this carbon. That's going to give us a product that looks like this. Okay, and so that's how we would do this. Now, we left this HOCH3, but if they said excess HBr, that means we have more than just one. What now can happen is that alcohol can attack another HBr, or it'll take another H. This would break. We'd now get this sort of structure. And it's protonated. So now we have our Br minus here. So what's going to happen? Right, well, if we did the SN1 mechanism, we'd have a carbocation and a methyl, which we know is really bad. And in this case, it's going to be an SN2 reaction. Br minus is going to attack that carbon, kick out this water, giving us BrCH3, and we have H2O. Okay? So that's one example of an ether synthesis, right? And so you guys can see that we're essentially all we have to do here is use a strong acid, right? It's going to bind. We're going to protonate our alcohol, and after we protonate the alcohol, all we have to do is either do an SN2 or SN1, right? So here's another example. And this one was given in a lecture. So you have OCH3 reacting with HBr. So what's going to happen? Well, the first step is always the same. The oxygen is going to grab the H, take the Br out, and we're going to get this. Here's the CH3, H, and the positive charge. And here's our Br minus. Okay, and so now we have to decide, are we going to get an SN1 mechanism or are we going to get an SN2? Because this is not symmetrical, right? Right here we have a secondary carbon, and right here, this is just a methyl. So that means we can either have this leave and generate a secondary carbocation. We know that here this is not going to just break on its own because we're not going to get a methyl carbocation, but we could have an SN2 here to cause that. So which one is it going to be? So it's much more favorable for an SN2 mechanism on a methyl than it is for a secondary carbocation to form, right? Because while they are somewhat stable, SN2 is very fast at a methyl. So we're going to have Br minus attacks this carbon, kicks this out, and we're going to get this structure. Right, and then Br CH3. Okay, so usually when handling ether cleavages, right, you have to look at the substitution of the ether. If we have, let's say, primary ethers, right, we're going to probably go the SN2 route, and especially if we have a methyl ether. And tertiary, we're going to mainly go with SN1, right, because we can do that carbocation. All right, and so that's how we handle ether cleavages. On exams, they're usually very clear with what pathway you have to go to. All right, and so in the next video, we're going to be covering a special type of ether called an epoxide. All right, so I hope this video helped you guys. See you in the next